Hello, everybody. I'm really excited to be here at FireBioLive and would like to thank FireBioLive for having me. My name is Jacob Derrick. I am a fire engineer in the UK. My background is in electrical engineering and also fire alarm and detection alarm engineering. Today, I'm going to be talking about fire alarm considerations for people with sensory sensitivities. So, in recent years in the UK, standards have advanced and our understanding of some disabilities have progressed. For example, those with hearing impairments and photosensitive epilepsy have been catered for through EN 54 Part 23 with regards to visual alarm devices. However, those with other sensory needs and sensitivities may not react as designers expect them to react in the event of a fire alarm, and those issues appear not to have been considered as far as others have. Inclusivity in the modern world is really, really important, and whilst most obvious situations are catered for with regards to inclusivity, there are some factors which are still unaccounted for. One of those is people with sensory sensitivities and those with special educational needs or hypersensitivity. The issue being of alarm sounders and the effect that it can have on these people. I really believe that in an ever-evolving world, as architects, as engineers, as technicians, designers, specifiers, really anyone involved in the implementation of alarm systems, evacuation systems, anything that's related to life safety, that we all have a responsibility to ensure that the systems we specify, design, and implement are as inclusive as possible. This presentation really is aiming to highlight the issues of people who suffer with sensory sensitivity and bring awareness around some of the things that we might be able to do when involved with projects in specification and design of these systems. The aim of the presentation is to increase the awareness of the Fire Industry Association guidance note, increase awareness generally of sensory sensitivities and the impact that they can have on building occupants, highlight how design considerations at early stages of projects can positively impact the built environment, provide some guidance to designers and specifiers on the questions to ask end users, which hopefully can result in better specification and design, and also guide alarm designers and installers and commissioners on some in situ changes and adaptations to systems which are already in place that might be able to be implemented for the betterment of the system and the improvement of the situation for the building occupants. One caveat that I will give at the beginning of the presentation is that whilst the guidance note is fairly wide-ranging, and I think that it is very applicable to a lot of situations, as with anything that we do in industry, it isn't going to be applicable to absolutely everywhere. And so trying to apply the guidance note in an umbrella type situation isn't going to work. A little bit of background on the guidance note. So I am privileged to mentor a young aspiring fire alarm engineer called Sonny White, who identified this issue when he began studying and learning 5039 Part 1. Sonny identified the problems and approached the Fire Industry Association, who kindly published the guidance note. And this session is, broadly speaking, based around all of the work that he's done in that note. You can see the hyperlink there where the guidance note is directly available from. So let's look at what a sensory sensitivity is. Those with hypersensitivities have a heightened response to stimuli. That could be audible, it could be visual. Sensory sensitivity generally could be described as part of wider conditions such as sensory processing disorders, and it is relevant to say that those with autism often suffer with a sensory sensitivity. Whilst sensory processing disorder and autism are different, there are many similarities between the two. It would be fair to say that autism could be considered and is often described as a hidden disability, And I think that that is part of the problem when us as designers and specifiers are looking at buildings. We don't necessarily see someone's disability because it isn't visually made aware to us. However, 1 in 100 people in the UK are diagnosed with autism, but those who haven't been diagnosed, we aren't aware of. And there are estimates of between 10 and 20% of the UK population suffering with some form of undiagnosed condition, which might mean that they have sensory sensitivity. That's not an insignificant proportion of the population. And when we consider how many public buildings there are where people go to, the impact on these people could be significant. Where a person is highly sensitive to loud and sudden noises, the adverse reactions can vary. However, generally, screaming, crying, running, freezing, hiding are all reactions that have been observed. As engineers in fire engineering and in other facets of engineering as well, we generally consider that when a building occupant becomes aware of a fire alarm, for example, that they're going to make their way to an exit. That simply isn't the case with those with sensory sensitivities. Emotional upset is a huge problem, especially in the educational sector. And people can become upset just at the thought of a fire alarm going off. So if, for example, if during the school day, pupils are aware that there is going to be a fire alarm test, the apprehension caused can be very significant. If the fire alarm goes off during the school day, then pupils, students, people who suffer from sensory sensitivity often suffer emotional upset for hours or potentially even days. The knock-on effect of that for their education is absolutely massive. If we look at current guidance, in the UK, BS 5839 Part 1 is the guidance document for fire detection alarm systems in non-domestic premises. Section 16 specifically deals with audible alarm signals. It's noteworthy that during this presentation, I'm only really discussing audible alarms. The guidance note does give guidance on visual alarms. There simply isn't enough time to discuss all of these issues today. Generally, in the guidance, 65 dBA, so decibel audio, is the sound pressure level that is an expected minimum to be achieved throughout the building in order to alert building occupants to the fire. There are some areas where this can be reduced to 60, and those are written in the guidance, helpfully shown in the diagram to the right-hand side. The recommendations in BS 5839 do state that in order to prevent excessive sound pressure levels, which can cause disorientation or even damage to hearing, a large number of quieter sounders is preferable to a few very loud sounders. There is acceptance in the guidance as well that between 2 to 3 dBA is likely only just perceptible as a difference in human hearing. If we look at objectives of what we're trying to do when we implement fire detection and alarm systems in buildings, there's some helpful discussion points in guidance. So firstly, in BS 5839, the objective of it is essential that alarm signals are sufficient in nature and extent to warn all persons for whom the alarm signal is intended, for me, is a really important functional type requirement. For educational settings specifically, if we look at Building Bulletin 100, it discusses looking to minimise the anxiety of pupils in an emergency, particularly the youngest ones. And again, looking at HTM 0503 Part B, although that is aimed at mental health and healthcare settings, there's obvious crossover with some diagnosed sensory sensitivities. And HTM 0503 says that causing confusion and distress to occupants is unhelpful. So if we look at all of these as contributing to the overall objective of what we want to achieve, and took these statements as the objective instead of just considering minimum success based on achieving a sound pressure level generally of 65 dBA, we can start to try and tailor systems for the benefit of the building occupants. Again, I think that primarily the guidance note is initially of help to those operating in educational settings, those who are operating in specific areas where we know the building occupants suffer from a diagnosed sensory sensitivity. It's noteworthy that this could apply to mainstream schools and not just specialist schools for the purposes of SEN students. A BBC article recently stated that SEN schools are hugely oversubscribed, and so pupils with SEN are now being sent to mainstream schools. There may be small classrooms specifically for their needs, and there are examples where, say, porta cabins have been put on school fields for the purpose of trying to adapt and create safe spaces for SEN students. So mainstream is as applicable as specialist schools. Looking at sound pressure, how loud something is audibly perceived to the humans, we can look at the commissioning phase. Commissioning sounders to be the quietest that they can be whilst achieving the 65 dBA minimum. It's fair to say that when systems are commissioned, they're commissioned in a standard normal state, and as long as 65 dBA or more is achieved, there tends not to be a lot of thought given to the situation. In actual fact, what we could do if the sounder, say, achieves 85 dBA, is look to use programming or onboard changes to that device in order to reduce the sound pressure. Toilets, changing rooms, anywhere where there are hard surfaces are often quite challenging with regards to audible devices. And where those areas are considered potentially to be wet areas, often the only fire alarm devices that may be available are weatherproof horn type sounders that output significantly more than, say, a bass sounder. And in that case, if we were to provide a device that outputted between 85 and 105 dBA, the sound reverberation off the hard surfaces is significant, and actually that's a really bad situation for building occupants. We need to be aware of the reduction to 60 dBA that's given in the guidance and look at implementing that where we can. The other helpful thing would be to assess whether we can reduce the audibility levels towards the exits of the building. So once students, pupils, occupants have started moving, say, out of classrooms, down corridors, towards stairs, towards a final place of safety outside of the building, there isn't necessarily as much onus on alerting them to the fact that the fire alarm is going off. So corridors and stairways are an example of where a reduced sound pressure level might be helpful. Collaboration with the end user and occupier. I'm going to talk about collaboration as being a really big part of how we can make changes, especially in those settings where students or occupants have special educational needs. The school or college teams, the academic teams, will often have a really good awareness of what may trigger the occupants more. And so engaging with those end users at an early stage can be really helpful to understanding what can be implemented at the design stage. All of that comes with a need to risk assess and to work quite heavily with management. And I'm also very keen to say that I recognise that schools can be used outside of normal school hours where perhaps the management and the staff ratios aren't necessarily the same as when the school is being used for its primary purpose. And obviously, in those cases, we do need to achieve minimum sound pressure levels attained in order to alert the occupants in those scenarios. One final thing is that placing external sounders on the outside of buildings or near to the fire assembly points for sensory sensitivity purposes can be really quite problematic. So again, on the theme of moving towards places where we want the sound pressure to be reducing as people get towards the outside of the building, the same can be said for external sounders. Once people have moved outside of the building and they're at a place of safety, such as the fire assembly point, there isn't so much of a need for there to be loud sounds there. So reducing those would be really helpful. Tone is an interesting discussion. So again, collaboration with the academic team or anyone involved with the building occupants might highlight that some tones are less problematic than others. So as an example, two-tone sound, which alternates no more than every 0.5 seconds and fades in and out slowly, might be preferable to a very fast changing two-tone sound. Similarly, and this is mentioned a lot in the guidance note, voice alarms may be a preferable route to alerting building occupants. They can be perceived as far less intrusive, and because they give information as to what is happening, sometimes that can be really beneficial for helping building occupants understand the situation rather than just being suddenly given an alarm tone, which can be quite disturbing. As a result of the work that's already been done with the guidance note published by the FIA, the Institute of Fire Safety Managers has recently granted a research grant to Sonny White to conduct research into SEN schools. I'm really pleased to be working with him on that and helping him conduct the research. And the study is aimed at assessing how 3 different types of building have been designed and the levels of consideration for sensory sensitivities that have been undertaken during the design stages. There's some really, really good future opportunities for research. So the first is consideration of wider public buildings. What I've discussed today primarily can be implemented in schools, colleges, academic settings where there is good management, potentially high staff to pupil ratios, and where we have a good understanding of who the likely building occupants are. We can't discount the fact, though, that with the 10 to 20% of the UK population we discussed earlier potentially having a sensory sensitivity, that the issue is wider ranging and can extend into public buildings, public spaces, anywhere where you might choose to go. Studies that also assess sound and tones would be very helpful in moving this forward more formally. Clearly, they come with ethical considerations as to whether we can subject people with sensory sensitivities to different tones and the challenges that that could bring. However, it might be helpful to understand if some tones were more challenging than others. Finally, future revisions of BS 5839 Part 1, which included some discussion and commentary on the need to include sensory sensitivity as consideration, and that potentially even made changes to the audible alarm requirements such that we can reduce the audible alarm sound pressures towards exits might be helpful. The potential actions that people can take away and use: awareness at the design stage of who the building occupants are, or who the primary building occupants are, would be helpful in deciding whether to apply the guidance note or whether, in fact, the recommendations in relevant guidance were the best thing. The end user, the academic staff, the collaboration I've discussed may provide some information on the building occupants. And again, once we understand that, we can then tailor situations appropriately. Undertaking a process similar to a qualitative design review, again in collaboration with any interested party, might provide a good route towards specifying, designing, installing, and commissioning the systems. Implementation of good practice, discussed earlier when I was talking about the sound pressure levels, would be good instead of trying to simply see the minimum dBA levels recommended in any guidance as simply the minimum, and as long as we've overachieved, that's fine. Flipping that concept on its head and saying it is a minimum, so let's try and achieve that and be aware that actually overachieving can be as problematic as underachieving, that would be a good step. Risk assessment of specific areas could be really helpful. Again, it's down to the occupant needs, it's down to the particular buildings, the particular project at any one time. But risk assessment might offer an ability to use variations to standards where everyone's aware of a reduction in sound pressure, for example. It's been fully risk assessed. It's been agreed as a variation, which is allowed under the recommendations of BS 5839 Part 1. And we use it for the improvement of the built environment for the building occupants. And then finally, the opportunities and the changes that can be made don't need to be limited to just new projects. With existing systems, if we can ask the same questions, perhaps maintenance engineers working on fire alarm systems can ask the end user questions of who the occupants are. Using modern technology, we could perhaps reprogram sounders to be quieter, or we could undertake a change of the audibility levels physically on the sounders themselves. So I think looking at the built environment and understanding that it's not necessarily just for new projects, we can look at existing buildings, again, might provide help and create a better environment for those with sensory sensitivities. So to begin the conclusion, I think for me, the 3 points mentioned earlier are really key in deciding whether you want to look at minimum recommendations or whether in fact looking at a functional requirement or a functional objective might be the right thing to do. Again, minimizing the anxiety of pupils in an emergency, that should be a functional requirement. Causing confusion and distress to occupants, being unhelpful, that's a key in deciding how we set up our alarm systems. Finally, I would like to ask everyone, can we change our approach to the specification, design, commissioning of fire detection and alarm systems from considering success of that system being based on achieving a minimum compliance objective, a minimum compliance target, and start instead by thinking about the people and how we can affect those people, how we can improve what compliance looks like for those people. Thank you very much for listening.
So thanks, Jacob, for a fascinating session on fire alarm considerations for people with sensory sensitivities. And thank you for taking the time to catch up with me now to find out a little bit more about this topic. So to start, by lowering the pressure of sound alarms or implementing voice alarms, although this is great for people with sensory sensitivity, does this pose an alternative issue for people who may be, for example, hard of hearing?
It's a really interesting point. I think if we tackle voice alarms first, no, voice alarms have their own British standard that's accepted. And I think if we can understand and kind of take for granted that a voice alarm is less intrusive for those with sensory sensitivities, we've already got everything in place to guide us as to the implementation of those systems, and they can be done completely compliantly under current recommendations. The one thing I would say with voice alarms is there is the need for an alert tone to be produced before the actual voice message is played, and so that alert tone could still cause a slightly adverse reaction to those with sensory sensitivities, but it might be better than a continuous tone, if that makes sense. The other issue you're right to bring up is one of reduction in sound pressure, then meaning that for those other occupants who have some other condition, they may not be alerted to the fire alarm. That's why, as I said in my presentation, it's really important that we sit down and we fully consider who the primary building occupants are, what the management of the building looks like. For a school, for example, is it going to be used outside of normal school hours where we might have those people who are hard of hearing in there? How do we tackle that? the guidance note and sensory sensitivities it's really important to consider. It's not a catch-all, and I think that's why I would always come back for the need for good collaboration and discussion with anyone involved in the running of the building, and ultimately good risk assessment as well of how the building is going to be operated.
And whose responsibility would it be to assess the occupants within a building and judge the possibility of installing an alarm system tailored better towards sensory sensitivities? Would this be monitored by someone other than the building owner?
Again, it's another really interesting point. There's a broad set of answers, I'd say. We're not going to get around all of it today. For existing buildings, they're probably the easiest. Obviously, in the UK, the responsible person, whoever that is for the building, is ultimately responsible under law for ensuring that fire safety is achieved. For existing buildings, I think if a new fire detection and alarm system was being specified and installed, those people who were directly in contact with the students or the pupils, the building occupants, whoever they might be, are going to have the best understanding. And so although they're not responsible, the thing I laboured on in my presentation was really that it's all about collaboration. It's all about talking to those people. So if you're part of a team or a company who has been approached by a building owner or an occupier to provide a new alarm system, asking the questions, does anyone have a sensory sensitivity? Is there anything that we need to know about the building occupants that could help us make this the right system for this particular building? Just asking that question. If they're aware of occupant needs, the people will tell you straight away, oh yes, we've got someone that's got autism, or yes, we're a school for special educational needs. And suddenly the conversation and the dialogue is opened and discussions can start. So I don't think it's necessarily about who's responsible, it's about getting that discussion. So that would be for existing buildings. For new buildings, there can often be a disconnect because whoever is asking for the building or letting the project building the building may not have a full awareness of these sensory sensitivities or even of special educational needs. They might be aware that the building is for that purpose, but the awareness of the impact of systems within the building once it's operational might be limited. I think what that does for new projects is to expose a gap currently in the way that we approach design and specification of projects between the end user occupier of the building, who might have a wealth of knowledge about the building occupants and their particular needs, and those people that may be far removed down a contract chain, who are designing a specialist subsystem, that now are just simply designing, installing a system to the recommendations of the British standard with no real awareness of who's going to be in the building, and that they're working on an assumption that the British standard will be the right solution because it achieves compliance with recommendations, where obviously I think we've highlighted today that that isn't necessarily the case.
Well, thank you so much for your session and for taking the time to talk to me. If anybody has any further questions for Jacob, then please do reach out on the platform. You can connect with him directly, set up a meeting, or ask your questions. Thank you.